So under symmetry, we are going to learn about bilateral symmetry. So let's write down bilateral symmetry. What is this bilateral symmetry? Okay. So let's say there is a small dotted line like this. We call this dotted line, the line which makes the symmetry, we call it axis means line of symmetry. What do we call it, Pute? Axis of symmetry. Let's say under this axis of symmetry, there was a figure going like this. And they are telling us, okay, draw the other side of this shape, so the axis of symmetry will bilaterally be symmetrical to this figure. So that means, Pute, what you have to do is make sure that you draw a line like this in the other side, but in a coinciding manner. Draw a line like this in the other side in a coinciding manner. Draw a line like this in the other side, like a coinciding, like a mirror effect manner, like looking at a mirror. What is this coinciding manner? Coinciding means, Putha, like a book. If you fold it, if you fold this thing, it should go and touch here. If you fold this thing, it should go and touch here. If you fold this thing, it should go and touch here. That's what coinciding means. Do you guys get it, Pute? So this is the example for bilaterally symmetrical figure. Let's write down what the meaning of it is. What? Bilateral symmetry. When a plane figure, when a plane figure is divided into two equal parts which coincide each other through when folded along the line. We call it axis. Oh, sorry. Is that good enough?
Yeah.
So this is what bilateral symmetry means. So in a bilateral symmetry, it should divide into two equal parts. That should happen definitely. That is necessary to happen. And also, it should coincide when folded along the line. That looks bad. It should coincide when you fold it around the line as well. But alright, Pute, let me ask you a question. Now, let's say I got a figure like this. Okay. And let's say that I am going to copy the same figure and keep it here. Is this bilaterally symmetrical?
No.
Why not? It's same in size, no, Pute. Both of the sides are same in size.
Sir, the second one should be in opposite way.
Why? Why not bilateral symmetry? Very good, your answer is correct. But what's the reason?
Because it has to be thick, like it's
Because when you fold it along the dotted line or the symmetry line, it should coincide, Pute. Very good. It should coincide. Coincide means what? Now, if I have my fingers like this, if I do it like this, can you see? It doesn't overlap. That's a coinciding. Yeah. But if I have my fingers like this, will it coincide? Yes. But if I got my fingers in the same way, will it coincide ever? No. Yeah. Alright, let me ask you all then this. Let's say that I got my axis of symmetry in this line like this. Yeah. Let's say I take this, but I flip it and then come and keep it here. Will this be bilaterally symmetrical to each other? Yeah?
yes.
Alrighty. Very good. Now Pute, remember this thing. Yeah? This line, we call it what? What do we call this line, Pute? This is not axis of symmetry. Because there's no bilateral symmetries. Yeah, but this is a axis of symmetry because there is a one bilaterally symmetrical or symmetry. Now let me ask you all a question. If I have a square shape like this, yeah, is how many bilaterally symmetrical or axis of symmetries do you guys think I can draw? Now I know this is a one axis of symmetry. Yeah. How many can I draw like that? Sorry?
Any amount of the multiple of 2.
What do you mean?
So like when you gave that short note, it didn't say like how much parts, so it's over 2 in the earlier small note. When a plane figure is divided equally into parts.
Yeah. So now this is the axis of symmetry. Do you agree with that, Putha? Yeah. But like that, yeah, I know this same square. If I take this same square, yeah, I can. If I take this same square, yeah, I can also draw another axis of symmetry like this, right? That is another axis of symmetry. Yeah. So like that, put it. Like that, how many different axes of symmetries can I make to this square? That's what my question is. How many different axes of symmetries can I make? I can take the same square and I think I can make axis of symmetry like this as well, right? Yeah. That is also coinciding and equal to each other. There you go, that's another axis of symmetry. Yeah. I think I can make another one like this, isn't it? There we go. That is also axis of symmetry. Is there anything else? I don't think so. So how many different number of symmetries are there? Number of symmetry is, how many different symmetries did we draw, Pute? We drew, I think, 1, 2, 3, 4. There were 4 number of symmetries. So the number of symmetries we have in this figure is 4. Is that clear, Putha, everybody? Okay. Alrighty. Then, can you all quickly draw these things, write these things which I did with you all? Yeah. And give your best try to show how many axes of symmetries or what is the number of symmetries this figure has. This is an equilateral triangle. All sides are same triangle. Yeah. In all sides same triangle, how many different symmetries will I have? So first of all, what I will do is, I will show you all what I think the axes of symmetries are, and then let's check using software which I use to check whether it's an axis of symmetry or not. Here we go. I think this is one of the axes of symmetry. Yeah, that is one. And I think this can also represent as axis of symmetry. And also, Pute, I think this is also an axis of symmetry. Like that. Alrighty. So the number of axes of symmetries are 3. That is what I think the answer is. Alrighty. Let's have a look whether that's correct or wrong. Yeah. Here we go. We have this equilateral triangle. Yeah. So I think, as I said, this thing, I think it's axis of symmetry. Let's check whether it's correct. Yeah. Can we see? Yeah. If I flip it around, yeah, they coincide each other nicely. No overlaps. Even if I take it like this, Pute, yeah, you can see that if I flip it around, there's no coincides. It looks good. Even if I flip it like this, Pute, it looks perfect. But if I take it like this, will that be axis of symmetry? No, because why? If I put it to the other flip, can you see there are overlaps happening, and there are some places where they don't even touch each other. So it's not axis of symmetry. Got it, Pudha? Everybody? Alright. If you all are done with that, let's check who can work out these 3 questions properly. And I want you all to send me the answers to my WhatsApp. Alright. This is a triangle where 2 sides are equal. Only 2 sides are equal in this triangle. We call it an isosceles triangle. Yeah. This is a diamond shape. And then here we go, a parallelogram. Oh, y'all should be able to remember them. We learned about them in grade 6, right? 2 sides are equal, like a rectangle getting tilted, parallelogram. And then here we go, a rectangle as well. Quickly draw all the number of symmetries all the axes of symmetries, and write down underneath how many number of symmetries do they have and send it to me. Yeah. Do it quickly and send it to my WhatsApp Pute. Yeah. Let's have a look. Pute. Yeah. Now this one is we call it, who can remember the name of a triangle where 2 sides are equal? Anybody knows? Y'all will let me learn this here. Anybody knows the word? Have you all ever heard about it?
Isosceles?
Isosceles triangle. Very good. Yeah, it's a isosceles triangle. In isosceles triangle, Pute, there's only one axis of symmetry. Yeah, there's only one axis of symmetry. Because you can't draw another axis of symmetry here. I'll show you why not. Yeah, because end of the day, even when I was going to school, I had an issue. Like, why axis of symmetry is not working for isosceles? Now, as I said, this one is axis of symmetry because I can see it coincide each other. Yeah, but if I draw it here, Pute, can you see? If I try to coincide the other flip over, can you see? It's not flipping over. It's overriding itself. Yeah, so it's not axis of symmetry. Got it? There's only one axis of symmetry. Now this diamond is actually a square tilted. So it will have how many axes of symmetry, Pute? There will be 4 axes of symmetry. One like this, one like this, one like this, and another one like this. And then the next one. Who got any axis of symmetry for the next one? Pute, this guy has 0 axis of symmetry. You will not have any axis of symmetry, Pute. If anybody got any axes of symmetry, show me how you drew it. Let's check whether it works or not. Yeah? Because I'll show you now for this thing. Yeah. Some people think, oh, this is the axis of symmetry because it gets divided into 2 equal parts. Yes, but when you flip it over, can you see? It's not touching each other. Yeah. Even if you do it like this, now sometimes people think, "Oh, this is axis of symmetry." Yes, it divides into two equal parts, but it doesn't coincide. It doesn't coincide. Yeah. A parallelogram doesn't have axes of symmetry, but a rhombus may have. There's no rhombus. Here we go. A rhombus may have axes of symmetry like this and like this. Rhombus means what? A square get tilted with it, like a diamond shape. It will have axes. Yeah. Can you see? There's a one axis of symmetry like this and another here. That's how it goes. Got it, everyone? Yeah. Cool. Then the next one. A rectangle. A rectangle will have only two axes of symmetry, which is like this and which is like this. Two axes of symmetries are there, not four. Why not four? Because if you draw the diagonals, what will happen, Pute? If you draw a diagonal like this, yeah, you might feel like both are same. But Pute, if you fold it, this will come and touch like this, Pute. It will not touch. This corner will never come and touch this corner here. You get it? So it's not axis of symmetry. So there it's not a symmetry. Got it, everyone? No problems? Yeah? Now this one, Puta, I want you all to draw it and send it to my WhatsApp. Everybody get a mobile and quickly do it if you can. Yeah. Complete this thing. So draw this thing. Yeah. And copy it in your exercise book and show me how will the symmetry work here. Yeah. Draw the full figure. Give your best try, Puta. After that, we will go to our new lesson today. The next lesson. So today we will probably manage to do 2 different lessons and finish off 2 chapters will be done. Now here look, alright, always what I used to do is this. So can you remember vertices, edges, the lesson we did about solids? Yeah? Always look at the vertices, that means the corner points. In this shape, we got a corner point here, corner point here, corner point here, right? So draw those corner points first. So here the corner point will be same because it's on the line. The length from here to here, it should be the same length from here to here. So the same length here, same length here. Here we go. And then Pute, all you need to do is follow the thing. Yeah. Here we go. And then you draw it like this, something like that. Yeah. This thing is very hard to get the work done because it's playing with me. That looks good. The first one. Next one. Here. This is a corner point. So what I will do is I will draw another corner point here and finish out that side. Got it? And then Pute, it goes a line like this. So let me draw a line like this. And it goes a line down. So let me draw a line down. And then it has a curve like this. So let me draw the curve like this. And it has like a big tummy like that. Big tummy like that. Here you go. That's it. Yeah, try your best to do it. I know that you can't do it for the best extent. Even I can't do it to the best extent. But make sure that you draw it in a way that it looks correct enough. Nobody is going to check your artistic skills here. Even though I got a for art, I don't even know how I got a for art when I was going to school. Here we go. Yeah, something like this. All good, Puta? Everyone? Perfect. Then, Pute, we are going to the next lesson today, which is about sets. Alrighty. So let's write down Pute sets. Yeah. What are these sets? Yeah. that helps us to represent data of elements, yeah, in an orderly manner. Yeah. Sets actually helps us to represent data in an orderly manner. Kali, are you okay, Puta? What's wrong?
Nothing, sir.
You are like, you are not looking okay for sure. Yeah. Are you writing down the things properly? Okay. Yeah. Then there's the one special thing about sets. Yeah. We don't write the same element more than once in a set. That's something we don't do, because end of the day, if I say, yeah, in my classes, yeah, there can be a student who is in two different classes, yeah, but when I say about my students, yeah, will I ever say that I got this person, like let's say as an example, Shenuk, let's say Shenuk is learning in grade 6 as well as grade 7. So when I say the students in my class are Shenuk, again will I say Shenuk again? No. Shenuk is a one person, right? He can be in different classes, but end of the day, he's one of the students. We don't say that his name again. Yeah, that's what it means. We don't use the same element twice. We don't just say the same thing. Yeah. So when we say sets pute, there are three different main ways we represent sets. Yeah. Sets can be represented in a descriptive manner. Yeah. Don't worry, I know that you might not understand what the hell is happening. You will soon understand it. Yeah. I'm just teaching you all how ABCD works here, and then you will know what this is. Descriptive manner. Yeah, or in other words, we call it inverse. Inverse. Or sometimes we can represent sets pute as elements. And the other way to represent sets, yeah, using in a Venn diagram. Yeah. We can represent sets in these three different ways. I will teach you about all these three different ways. It's very easy to remember. Sets can be represented in three different ways like this. We should the same Putta. Express, let's say that we got a question like this. Are you guys done with writing? I suppose because you all are in grade 7, I think that you all are writing a little bit faster than before. Yeah, so I'm going a little bit fast. If I'm going too fast, let me know, okay? Express the set A. Yeah, so the set name is A. Don't worry, I will teach you what that means. And what is this set A? Letters of the name Janaka Joseph.
The screen is a little bit blurry.
The screen is a little bit blurry. Is that getting better or not really, Pute? No?
I can see a little bit.
Is it the same to everybody? Is my screen is blurry? No?
No, sir. It's
Okay. Let's give Mashayan a moment. Maybe he's... Mashayan, maybe I will put it to the waiting room and take you back. So then your internet connection will get refreshed, okay? So hold on. As soon as I put you into the waiting room and take you back, like it will take only like 1 minute maximum, okay? Alrighty, he's back. Is that better, Mashayan Puta? Yeah, there we go. The best way is sometimes just refresh the connection. So expressly set A, the letter of the name, letters of the name, Janaka Joseph, in the descriptive manner. Now see here. I forgot the R there. Even up here. Descriptive manner. The next way is as elements. The other one is in when always V is capital, yeah? I'll tell you why in that. Alright. Everybody good? Now Pute, if they say set A, yeah, we just write a and we put equals. Yeah, so I'm teaching you how to write it in descriptive manner, yeah? A equals. A is the main thing. A represents the letters of the name Janaka Joseph. Descriptive manner means we write A equals and open a curly bracket. Open a curly bracket. Can you all know how to draw this curly bracket, Pute? You draw like a 2 and then like a thing. Yeah, this is how you do it. Open a curly bracket. Yeah, and write down whatever the question say as it is. Letters of the name Janaka Joseph. Just write it like that. Yeah? In words, you just write it. Letters of the name or word. In this case, they say name, no, so let's use name. Name Janaka Joseph. Usually, Pute, we write these things in capitals only when the question is given, but here the question is not given like that. Let's write it. That's the way they have put the question. Then, the next one. As elements. Elements means as elements here. So, what are the letters you can see in my name, Pute? What are the letters you can see in my name? So, the second way of writing as elements. A equals where we open a curly bracket. What are the letters you can see? In my name, what are the letters are there? Can you all tell me? Talia, what are the letters you can see here? English alphabetical letters in my name. Tell me one of the letters.
J.
J is there. Very good. And then we put a comma. Shanuk, can you see any other letters in my name? Come on, there's a lot of letters here. English alphabetical letters. Say me anything you can see.
A.
A is there. Very good. Mashayan Pute.
A.
Sorry?
E.
Sorry?
E.
E? Oh yeah, Joseph got E. Okay. Yeah, Pute. What are the letters you can see? Any letter you can see? Yeah, are you there, Puta? Okay. Okay, Talia, what can you see, Puta? Any other? Okay, K is there. Any other letters? Anybody?
H,
H is there. Okay. Any other letters? Sorry?
P,
P is there. Okay. Any other letters?
S,
S is there. Any other letters, Puta?
O,
O is there. Anything else? N is there.
N,
N is there. Yeah. Janaka, N is there. Any other thing? No, that's it. Here we go. We wrote the letters in here. Even though there are multiple A's, are we going to write A? No. When we say the letters, A is already there. That's it. Do you guys get what I mean there? What I meant up here? Yeah, we don't write more than one. Same anyway. Got it, everybody? Then Pute, write in as a Venn diagram. Why? What is this Venn Pute? Yeah, this Venn diagram thing is something which helps us not in grade 7, but when we go to grade 11 Pute, it helps us a lot to understand very difficult worded questions in a much more easy manner. Yeah, but as a small example, this Venn diagram came out of a person called John Venn. Yeah, John Venn is a person. Now you don't have to remember these things, okay? This is something, a little bit of history. I used to be a person who loves to learn. Like whenever I learn something, I always try to figure out why did it happen, how did it happen, yeah, what's the reason why we are learning it, yeah. So this is something for your knowledge. John Venn is an English person, yeah. A English person means a person who is coming from England, yeah. This English John Venn, yeah, was born back in 1839, if I'm not wrong. No, 1834, yeah, and was living until 1920 something, 23, yeah, 1923, yeah. This is the time he was living. Why did he represent this thing? There are many controversial ideas about it. Some people say that he wanted to get a knighthood. Some people say like this and that. But whatever he did, he still used it. Now it's been more than almost 200 years. Yeah, very close. Now after another 9 years, it will be 200 years since he was born. Yep. But this so-called Venn diagram system have helped us a lot to understand data, and actually Pute, for statistics as well, these Venn diagrams are very, very important. Yeah. But anyway, in a nutshell, what is this Venn diagram? Put in the elements or these things in a diagram, Pute. All you need to do is write A, draw an arrow, and then you can select whether you want to use a square or a circle. I usually use a circle. Yeah. Draw a nice circle or an oval type of a thing and write down all the elements. That's it. Yeah. J is there, A is there, E is there, K is there, H is there, P is there, S is there, O is there, N is there. This is what Venn diagram is. Got it? Everybody? Very easy. Just draw it as a picture. So no commas, no curly brackets, just put it in a picture. That's it. Got it, everyone? No problems? Yeah, but remember, whatever they say, the set A, then you have to write A equals A equals A equals. If they say set B, you will write B equals B equals B equals. Alright? Okay, let's do another question together. Now the next question is, yeah, the same thing I want you all to do, yeah, for your name Pute. Yeah. So write down, express the set B, letters of name, and write down your name here, Puta. Yeah, write down the name, your name here, and write it in descriptive manner. Write it in as elements. Write it as a Venn diagram. Yeah, quickly do it. Now these are about letters of a name. How much other stuff as well. We will learn about them. Let's quickly get it done. Alright, Pratay. Then maybe let's go to the next question, set of questions, and let's do it together. Yep. Okay, here we go. So here, Puta, everybody come here. K equals 4, 8, 12, 16, 20. Represent K in a Venn diagram. So what should I do, Pute? I will write down K and an arrow. Always remember it's an arrow here in Venn diagrams. And then I will draw a small, like a circular shape. And then write down the elements here. What are the elements we have? Yeah, 4, 8, 12, 16 and 20. That's it. Got it, everyone? Then the next one, write down K in terms of common properties of its elements by which elements can be clearly identified. So that means they are asking to write it in descriptive manner. Yeah. What will be the descriptive manner of this K, Pute? 4, 8, 12, 16, 20. What are these 4, 8, 12, 16, 20? Who can tell me what it is? What is this 4, 8, 12, 16, 20? What do you think these numbers are? What numbers are these?
4
Sorry?
times 8.
4 timetables until? It's not everything. Yeah, 4 timetables until 20. Yeah. So we can write down, Pute, what are the common properties? Multiples of 4 until, yeah, until 20. Do you guys understand it, Pute? Multiples of 4 until 20. That's the common thing. Got it, everyone? No problems? Okay. If so, can you all do the question number 4 and send me the answers in the chat? These answers can be sent in the chat. Quickly do it, Pute. Everyone. Alright, Pute, let's quickly have a look at the answers and then we will have a break. Yeah. Express x in different form by writing elements in curly brackets. Okay, let's write down x in curly brackets. X equals curly bracket open a comma e comma I comma o comma u. And then they are asking to write it in common properties. Pute, we know x equals and curly brackets. Always remember, keep the bracket. Yeah, vowels. Vowels in English alphabet. Vowels in English alphabet. That is what it is. Got it, everybody? Alrighty. The very last question. Let's do it together. Represent the set of multiples of 5 between here to here. Okay. By writing a common property, which elements can be clear. Okay, they are not saying me a letter for set, right? So you can use any letter you like. What letter are we going to use? Let's maybe use letter C. Yeah, C is the set. Always a set should have a letter. Yeah, C equals. And then let's say the common properties are multiples of 5 between 6 and 25. That's it. That's the answer there. Okay, who can tell me what are the elements here? Can somebody quickly tell me the elements? What are the answers here as elements? Multiples of 5 between 6 and 25. What should I write for that?
10, 15, 20.
10, 15 and 20. That's it. Can we write 25? No, because it's between. You should not use 6 or not use 25. And then the last one. As Venn diagram, you draw a C and you make a nice circle or a square or a rectangle, whatever, a closed shape. And then you write down 10, 15 and 20. That's how you do it. Yep. I will be sending y'all some questions to do at home. So please ensure that y'all get it done. Yeah. We pretty much successfully finished 2 different lessons. It's very good. And yeah. So Pute, in this case, let me quickly tell you all what we need to do, what's going to happen. If we go in this pace, by the end of March, yeah, by the end of March, we should be done. Let me quickly find out. Yeah. By the end of March, we should be done with our first term syllabus. Yeah, actually, yeah. So that means around February, the very end of February, first beginning of March onwards, we will start to do revision. If we go in this pace, and the whole entire syllabus should be done very quickly. Yeah, just like last time. Yeah, but we will have more time to get things sorted out really quickly. This less, yep, yeah. There's a lot of good lessons, and it will be very, very good. Very easy because we did grade 6 very well, so grade 7 won't be that hard at all. Yeah. Anyway, I'll see you guys next time then. Have a great week ahead. See you guys then. Bye bye. Bye bye.